Hello, I'm Enrico Saccon and welcome to the accompanying video for the conference paper When Prolog Meets Generative Models, a new approach for managing knowledge and planning robotics applications. Let's begin with a brief description of the general workflow of this work. We start with a natural language description of the environment and the tasks that we want to complete. We use a large language model to create a knowledge base in Prolog from which we extract a total order plan and subsequently we extract a partial order plan. We move then to a Python script which is able to extract a simple temporal network from the partial order and to check its consistency by checking for negative cycles. When the simple temporal network is consistent, we extract a behavior tree which can then be executed. Finally, we monitor the execution in order to grasp all the failures that can happen and change the knowledge base accordingly. One possible example of query is the one shown on the right, where we have two blocks on a table and two robotics arm available, and we want to stack the two blocks on a new position. Here we see how we can interact with the LLM. We provide a series of test examples, and then we provide our new query. Once we submit the code to the large language model, we wait for a response, and once we are provided with a response, we check for the validity of the test case. If it's valid, we can simply go to plan. Otherwise, if it's invalid, we are able to fix the plan inside the fix section. After that, we call the Prolog algorithm, which extracts the total order plan, which is shown on the left, and subsequently the partial order plan, understanding the causal relationship between the different actions. At this point, we are able to extract the simple temporal network, and we also add the constraints on the duration of the actions. Finally, we extract the behavior tree, which allows us to actually run the experiments. In this case, we are running the test case shown before, where two blocks are on a table and they have to be stacked. As you can see, the two robots move at the same time, reducing the total amount of time that would have been needed. And that's it. Thank you for your attention.